For NAE Grand Challenge, we had access to clean water. My group did comparing the water quality of the Ganges River along various locations. My name is Daisy Alvarez, and my partners were Gabriela Alvarado, Abraham Duarte, Utiain Femu, Arafat Oladipo, and our TA was Bryant Yu. Our professor was Dr. Koda for Engineering 1331. A little bit about our background. So within such a populated country like India, healthy water sources have become more and more limited for new families. The data we collected contains different components of the water quality from the Ganges River along the various locations. We had two standards, the Bureau of India and WHO. These are provided to compare the different health qualities from our data we collected. The code will overall help the user determine which location will suit their needs the best to have a healthy life in India.
For our data validation, we checked that location, chemistry, and standards were all string arrays. We checked that our data 1 and data 2 were all numerical matrices. We checked that our dimension for our matrices matched the string arrays we had. We checked to ensure that user made selection with every menu that popped up. Location, we go on to ask them to select the standard they would like to follow. However, if the user makes no selection on location, we keep on prompting them to select a location until a selection is made. If the user makes a selection of standards they would like to follow, we go on to ask them to select a preferred component. However, if they make no selection of standards, we keep on prompting them until a selection of standard is made. After the user selects a preferred component, we go on to output the safety levels of that component at the selected location. After outputting the safety level components at selected location, we ask the user if they would like to check more location. If the user selects no, the program ends. If the user selects yes, we ask the user to select the number of components they would like to check at all locations. We then prompt the user to select the desired number of components. Then we output the results for these components over all location and display the graphs, and then the program ends.
Our first menu option is a list of all the locations in the Ganges River the user is able to choose from. Our test case shown, we chose the first location from our menu option to check. The second menu option lets the user choose what standard to follow. We decided to compare our component levels to the Bureau of India standards. After choosing the standard, we then decided what component to check. The component we checked was pH. This then outputted a formatted statement in the command window telling us what component we had, the level the component was in the water, and the location chosen, and the safety level. Here, we had the pH level at the location, and it was determined to be at a safe level. To determine safety, it had to follow a certain range. It couldn't be too far off from the chosen standard level. Here, the pH was considered at a safe level compared to the Bureau of India standard because it fell within the range we set. When asked to choose another component, we decided to choose no, but this option would allow the user to select another component and check the level for the same location previously chosen. Then we proceeded to select yes when asked to compare all the locations. This menu option is to let the user compare up to 3 components of their choice across all the locations. When asked how many components we wanted to check, we chose 1, and the component we checked was pH. In the command window, we had another formatted output that listed all the locations and their corresponding pH level. Along with this, we had a graph with a line representing the standard pH level. The standard pH level was graphed based on what standard the user had chosen earlier in the code, and in this case we were graphing the standard pH level from the Bureau of India. On the same graph, we have points representing the pH at each location. All the points above the line and within the set range are considered safe, and any point below the line was considered unsafe. Our inputs include the selected location that the user has chosen. We will then have them select a standard to follow, a water component to compare with the standards, and then we'll ask the user if they wish to compare all locations. If they choose to do so, we'll ask them how many components they would like to check, and then what components specifically they want to check across all the locations. Our outputs include stating the safety level of the water component at the selected locations, and at the end, if they have chosen to check for all locations, we will display graphs for the selected components to check across those locations.
Our program incorporates features that we deemed necessary to make it more efficient. We made use of a lot of menu options, f-printfs, s-printfs, while loops, for loops, and if statements to give conditions in our code.
In the program, we give the user an opportunity to make different selections such as the locations, standards to follow, chemical components to compare with chosen standard, and then our code eventually outputs these locations, their values, and the safest location. Eventually, a graph is also shown and it shows the chemistry across all locations and compares it with the chosen standard. While the code is running, if the user were to cancel a menu option or choose no option, our code creates an error and terminates. The safest location is determined when the chemical component is within 30% of the chosen standard. But this does not determine the user's choice. Hence, all locations as well as the value for the chemistry is outputted to the command window to guide whatever choice the user will make.
In conclusion, our program allows the user to check whether or not water is safe or unsafe at particular locations when compared to the standard selected, allowing the user to become informed. Moreover, the program displays a graph comparing the selected water component across all locations as well as a line of the chosen standard. One of the limitations for our program is that the user only has a limited amount of locations to choose from. Another limitation is that the data is subjected to change over time and does not account for the flow of water. Finally, although our code informs the user of the ideal location, it ultimately comes down to the user to choose a location, so our program serves as more of a suggestion.
That concludes our NAE podcast. We hope you enjoy it and thank you for watching.